This video is basically the second part of electrochemistry. So what we're trying to do in the second part of electrochemistry is we're going to connect ideas that we've learned in other chapters of electrochemistry. So the first thing we learned was in a reduction table, it's your best friend. And the reason why it's your best friend is because what you can do is you can figure out how to build an electrochemical cell. You can find E cell voltage for it and all those things using the table. So let's talk about a few other things that you need to know about electrochem. First thing is, if E cell is positive, we say a reaction spontaneous. If E cell is negative, we say the reaction in the forward direction would be non-spontaneous. And then finally, if E cell is 0, we say the system is at equilibrium. Now, one of the things you notice is there's a relationship between delta G, E cell, and Keq. These are all really key big concepts in chemistry. So if we basically have the value for E cell, mathematically we can find delta G, or we can find Keq, and it works both ways, actually. You could find one from the other, and you're expected to know that when you take AP Chem. So, first thing, if I would get E cell, if I calculate out E cell, all I have to do is plug into this equation. Negative N times F, which is Faraday's constant, times E cell, gets me delta G. N is the number of moles of electrons when you cancel an equation, when you cancel the electrons. So number of moles of electrons to cancel, basically, in an equation. When we do lowest common multiplier and redox balancing, that's what N is always equal to. F, Faraday's constant, I'm going to round it off a little bit, is 96,500 joules, right? Joules per second, or a coulomb. So it's joules basically per second. And finally, E cell values in volts. E cell is just the value we calculate by adding the redox and the oxidation reactions together. Other thing you need to know is you have to be able to calculate the equilibrium constant for a redox reaction as well. And you're provided this exact equation in your AP booklet, but you have to be able to use it. If you notice, my E cell value is right here. So I have E cell right here. You should also notice I have my N number there, and then I have 0.0592 on the bottom, and it equals log of K. So all I'm going to do is, in this case as well, plug in, and it's a natural relationship, allows me to connect equilibrium and E cell and calculate it one way or the other. So a typical type of problem is they will ask me to find delta G and Keq for this reaction. First step is I'm going to start with my reduction table. So I'm going to come back to my handy dandy reduction table, and I'm going to find each of the values. Ag plus an electron is right there. Copper 2 plus 2 electrons to copper solid is right there. I know that this is my cathode, this is my reduction, this is my anode, this is oxidation. So I automatically know I'm going to flip this. So this is positive 0.34, which is ultimately going to give me negative 0.34, and then I have, this is already 0.80 right there. So let me go and start on the reaction. So the first thing I'm going to do in my problem is I'm going to do the reactions. So I'm going to go Ag plus an electron, this is a reduction, is going to be Ag as a solid, and that has a value of positive 0.80 volts. Then I have copper. Copper is a solid, is going to produce copper 2 plus 2 electrons. It's an oxidation, so since I flipped it over, I get negative 0.34 volts. Before I go to get my overall reaction, I have to make sure my electrons cancel. Right now I have 1 and 2. So I'm going to multiply the top here by 2, so I'm going to get 2 of these. 2 and 2, and I don't touch the value at the end. So that means my value that required to cancel the electrons, if you're keeping score at home, is my N number is going to be 2, because it's the number of electrons required to cancel basically in an equation. So my N number is 2. It's one of the 2 values I need to be able to calculate Keq or delta G. So then I do this. I basically go through, and what I'm going to do is I am going to now add the 2 reactions together. So I'm going to cancel them. So I get 2 Ag plus Cu as a solid, arrow, 2 Ag as a solid, and then on plus Cu2 plus. When I add these 2 together, I'm going to get positive 0.46 volts by adding the 2 together. So I know the reaction's spontaneous already. I'm good to go by the E cell value. But they want me to do a few more calculations, and they're easy, so I will do them really quickly. So, first one, find delta G, they said. Well, I know my N number is 2, so it's negative N times 96,500, and then my E cell value is 0.46. When I pop all those into my calculator, and do my calculations, I end up getting when I calculate them all, I'm going to multiply it all. I'm going to get negative 88,000 joules. Since Faraday's constant is in joules, it will spit my delta G out in joules. So then what I do is I divide by 1,000, and I get negative 88 point, it's actually going to be 88.8. I left the 8 up there. Negative 88.8 kilojoules. Which makes sense because I said this was spontaneous. Since the reaction is going to be spontaneous, I would expect my delta G value to be pretty negative, and it is. Second thing they asked me to do, they asked me to find Keq. Well, I have all the materials I need, so what I'm going to do is I'm going to take my N, which is 2. I'm going to take my E cell, which is 0.46, pop it in for that, and I'm going to divide by 0.0592 equals the log of K. So then I'm going to pick up my handy-dandy calculator, and I'm going to go 2 times 0.46 divided by 0.0592 gets me 1554 on this side equals the log of K. To get rid of log, I'm just going to raise this side to 10. So I'm going to go 10 to the 15.54. And ultimately, I end up with rounding for sig figs. How many sig figs in that sucker? If I do 2 sig figs, I would get ultimately I would get 3.5 times 10 to the 15th for Keq. Which again makes sense because we said the reaction was spontaneous, which means it's thermodynamically favored, which means it happens, which means we would end up with a lot of products and very little reactants. So I would expect my Keq value to be very large, so past 1. So 3.5 times 10 to the 15th is a very large Keq number, which makes sense, which ultimately tells me that I'm on the right track because I know the reaction's spontaneous, so it will go very far forward, making lots of products and very little reactants. All right? So this is the second key piece in electrochemistry. Have a good night. Make sure you complete your homework and show your work. All right? Thanks.